Hello students, welcome to our machine learning lecture series, lecture number 8. Today we are going to discuss one of the most important topic in the machine learning subject, that is random forest algorithm. Okay, let's continue the session. Random forest definition. Random forest is a tool or supervised machine learning technique used to make predictions by combining the results of many decision trees, multiple decision trees. Basically, a random forest is a supervised machine learning technique that makes predictions by combining the results of many decision trees. Example, each trees look at different parts of data, and forest uses vote or average from all the trees to make final more accurate predictions. Here, why each trees look at different as we are combining predictions of multiple decision trees. Each tree look at different parts of data, and forest uses vote or average method. Both are same. Average method means what? Average of all the predictions, all the decision trees. Average predictions of all the decision trees to make final more accurate prediction. This is about random forest. Okay. Next. Assumptions of random forest. Independence of trees means here in each decision tree in the random forest is built using a random subset of data, and trees are assumed to be independent of each other. Here prediction of one decision tree is completely independent of prediction of other decision tree. That is independence of trees means here each decision tree in the forest is built using a random subset of data, and trees are assumed to be independent of each other. It is clearly mentioned that trees are assumed to be independent of each other means trees of prediction of one decision tree is completely independent to the prediction of other decision tree. Okay, next. No assumption on data distribution. Random forest doesn't require to follow any specific distribution or pattern. Means there are many kinds of distribution like normal distribution, binomial distribution, these kinds of distribution. Here in random forest it doesn't require to follow any of the specific distribution or pattern. Okay, this is about no assumption of data distribution. Feature importance. It assumes that some features are most important compared to other for making predictions, and it automatically identifies those important features. Here here in a data set it contains lots of features. In at that time but only few features are helpful for our prediction to solve our problem. At that time random forest automatically identifies those important features and store at one side, used to make predictions. Okay, this is about feature importance. Okay, once again I will repeat. Assumptions: independent of three, where prediction of one decision tree is completely independent of prediction of other decision tree. No assumption of data distribution. It doesn't follow any specific distribution or pattern. Feature importance. It assumes that only some features are more important compared to other, making predictions, and it automatically identifies these important features. Only the features which are most useful for solving the problem, the random forest automatically identifies it. Components of random forest. Decision tree. Actually random forest is an extension of decision tree. Okay, here decision tree. Here small models make decision by asking yes or no questions based on data. Okay, as we discussed yesterday, if it is raining, yes or no, like that, means it asks yes or no based questions and make decisions. Example, a tree might decide if someone will buy the product by asking, is a person older than 30? Yeah, if yes, go one way. If no, go other way. This is yes, it makes decision based on yes or no based answers. Okay, bagging. It is also called as bootstrap aggregating or bootstrap aggregation. Training each time on a random mix of data, so the each tree is slightly different. Okay, training each tree on a random mix of data, so that each tree is slightly different. Means there will be multiple decision trees, so each tree will be slightly different compared to other at the time of prediction. Okay, when we mix it randomly, then each tree will be different of each other. Okay, if you have 100 piece of data example, each tree again on the different set 70 random pieces. Generally, when we are training a data, we will allocate majority of data for training and minority of data on testing. Means 70% for 70% or 80% we will allocate for training the data, training the model. 20% we use to test the model, because training is used to train the model. Training helps understand about the data to the model. Test evaluates that what the model has learned from training. Okay, this is about, that's why we allocate 70 to 80% data on training and 20% data on testing. Okay, next example, if 9 trees says yes and one say no, the final decision will be yes. If predicting the number, it averages all the three predictions. Okay, it follows majority pattern. If majority of the decision trees say yes, then it follows that predictions. If majority of decision tree says no, then it follows no. Okay, this is about components. Okay, advantages of random forest: high accuracy. Okay, high accuracy means why it is good. Random forest combines multiple trees, many trees, to make decisions, which usually leads to better predictions and higher accuracy compared to single decision tree. Example, it's like asking many experts about the opinion instead of one. Like ask, if you want to perceive a course, you ask, or if you ask only one person, he will say only one answer. If you ask many other friends or colleagues, etc., they will give different kinds of opinions and ideas. That will be better to understand and analyze and make decision. So here random forest combines many trees to make decision, which is usually leads to better predictions and higher accuracy compared to single decision tree. If asking single person gives only one idea, asking many persons gives multiple ideas. That helps to make better decisions usually. Okay, next, handling missing data well. Why it is good? Random forest is more accurate, is still more accurate predictions even when some data is missing. Okay, if that is why it is well at handling missing data. It can still be more accurate predictions. It can still make more accurate predictions even when the data is missing. Example, if you don't know someone's income, it can still make good guess based on their age or location. Okay, next, reduce overfitting. Okay, why it is good? By using multiple trees and random subset of data, random forest avoids overfitting. Okay, example, it's like testing many different solutions and picking the best instead of just memorizing one solution. Okay, by using multiple trees and random subsets of data, random forest avoids overfitting. Okay, it's like testing many different solutions and picking up the best instead of just memorizing one solution. It tests some group of solutions and picks the one among them which is best. Okay, this is about reduce overfitting. Okay, limitations of random forest. Slow prediction. Random forest has many trees, so making prediction can take long time, especially with lots of data. If there is one tree, then the prediction work is very fast. As it contains predictions of multiple decision trees, it may take long time, especially when we have more and more of data, lots of data. Example, it is like asking people to advise instead of just one, which takes more time, as we discussed earlier. Asking advices to multiple people may sometimes take more time. Hard to understand. Since it uses many trees, it is hard to figure out why it is made a particular decision. Okay, example. It's like a group of people giving different answers and you can't easily figure it out. Why they said what they did. Okay, if you are in a group of 10 people, everyone will say different opinion. So in that, if they say different opinions, all the nine members, remaining nine members says different opinion. Sometimes you may feel it as hard to figure it out, which one to finalize, which one to take decision. So it will be a difficult task. This is about hard to understand. Limitation, a continuation of limitation, needs lots of memory. Storing the trees takes up lots of memory, especially with big data sets. If a data set contains 10,000 columns or 20,000 columns or 20 features or 20 labels, if the data set is too large, then it takes up lots of computer memory with big data set. Okay, example, it is like storing many books in a small room. If you store 10,000 books in a one single room, then how it will be? It will be like crowded. Sometimes it will be like a garbage also. Okay, next, applications of random forest. Classifying emails. Random forest can be used to classify emails as spam or not spam. This is also like same. It is used for classification tasks as well as regression task. Even random forest also used for classification task and regression task. This is a similarity between random forest and decision tree. Okay. Example, it looks at different features like sender, subject, words in the email to decide if it is spam or not. Next, predicting diseases. Random forest help predict disease, whether someone will get a disease based on their health data. It analyzes the health data of a patient and decide and help predicts whether he will get a disease or not. Example, it looks at factors like age, weight, lifestyle to predict if a person is at risk for a disease like diabetes. Okay, based on the health history, based on the age, weight, lifestyle, based on the habits, it predicts the risk of disease like diabetes, etc. or any other. Okay, next one. Continuation of applications, stock market predictions. It predicts stock market based on past data. Example, it looks at past stock prices, trading volume and other factors like to predict future stock movements. Okay. Basically, it looks at past data, even in the case of healthcare. Even it looks at past health history. Here it looks at past stock market data and analyze future movements. This is about applications. Okay. Okay, that is the end of the lecture. Hope I guess you all have understood my lecture. If you please like my video, then please like, share and subscribe to my channel, Visionary Tech. We will meet with more and more interesting concepts. So thank you. We'll meet in next class.